Hello and welcome to Statistics Lessons. This is the second of 3 videos dealing with normal distributions, and in this one we're going to talk about using a z-score on for a normal distribution to find what a probability is. So this is your classic standard normal distribution. The reason I say it's standard is its mean is at 0. And notice how the horizontal axis is labeled. It's labeled with z-scores. A z-score of -1. I know these pens are fussy, but I still need to try it. A z-score of -1 looks like a boundary there. Now, if you wanted to know the probability of having a z-score less than -1, it would be all of this area here. If you wanted the probability of having a z-score greater than -1, it would be all of this area here. Now it's pretty straightforward when we look at how we do this in the calculator to find the z-score of the probability of z-score less than -1. Sometimes you might, if you wanted to find greater than -1, just like we did with the binomial CDF function, you might have to find the probability that your z-score is less than -1. And then do 1 minus that number, because whatever this adds up to, the rest of this area plus that have to add up to 1. So this is a standard normal distribution curve that you're looking at. And the important numbers on that are z-scores. And if you remember when we did, we talked in earlier lessons about z-scores, a z-score was your data point minus the mean of that data set divided by the standard deviation. It told you how far. So the x minus mu just gives you the difference between, if this was just your mean and this is your data point, the difference between the two pieces of information. But when you divide that by standard deviation, you scale the result to be in terms of standard deviations. And we had said that if you had a standard deviation less than -2, a z-score less than -2 or greater than 2, then your data point was unusual. And we'll talk more about that and what that means. So for no matter what your data set was, once you turn it into the standard normal distribution, the z-score of a -1 has the same meaning for every data set. A z-score of a 2 has the same meaning for every data set, because it takes into account the characteristics of the whole set that are mean and standard deviation. So remember, that's how we calculated z-scores in the past. So now what we're saying is, what if you knew the z-score for what you were interested in? So in the case of a bone density test, somebody does a bone density test on me and they get a z-score for where I am, and that's how the doctor tells whether or not I'm within the range of normal. All right, so let's move on. I need to close that and click on that, and then I can go down that. There we go. So how do we find a probability when we know a z-score? Now this holds true for probabilities for data sets that are normally distributed. So we're going to make the assumption that everything we're talking about here is normally distributed. And usually when you're talking about populations, you are talking about normally distributed, large populations. So we can find areas using technology or a table. We're not going to use the table. We are going to use the TI-84 technology. So I'm going to skip through these next couple of slides here. I don't want to go too fast because it'll get ahead of me. But there are ways. Before we had technology, like when I learned statistics, we had to look things up in tables and make decisions based upon information in tables and interpolate values and things. We don't have to do that because our calculator basically has those tables built in some sense. When you work with a graph, you want to avoid confusion between z-scores and areas, but that's working with a table. We're not working with tables. Again, here's the discussion of tables. Now, sometimes, even with our technology, it's of interest to find the area to the left of some z-score, or the area between two z-scores, or the area to the right of a z-score. We will take a look at this. Now, this example fortunately uses the calculator and shows you how to use the calculator to do the calculation, so this will work out well. A bone mineral density test can be helpful in identifying the presence or likelihood of osteoporosis. Many women, they get to be a certain age, they have this test done. The result is commonly measured as a z-score. The population of z-scores is normally distributed with a mean of 0 and a standard deviation of 1. So these test results meet the requirements. So they take a whole bunch of measurements, and they may not measure in z-scores, but they turn each data point into a they turn the data into a standard normal distribution, and therefore all you need to know from that point on is once you test somebody and then you get their data, what z-score does that correspond to, and therefore what percentage of the population are they in. And if you're in a percentage of the population with extraordinarily low bone density, they might want to address it medically. So this is used in medicine all the time. This is just one example. So the graph of bone density test scores is shown here. A randomly selected adult undergoes a bone density test, and you want to find the probability that this person has a bone density test score of less than 1.27. So there's a z-score of 1.27. You want to know the probability that somebody is less than that. If you take a child to the doctor and they weigh them and they say you're in the such and such percentile, this is how they do that too, or you weigh them or you measure their height. So if you did it in the table that we're not using, it was showing you the area from negative infinity, basically, for z all the way to here is 0.8980. And that's done with calculus, and that's calculated in those tables for you. But the calculator does the same kind of thing, though. So in the calculator, we want to find the probability that the bone density test score is less than 1.27. So to find out what that area is using the calculator, we use the normal CDF command. And the way you get to that command, and there are other things posted in your course Blackboard site that tell you how to use these commands, but you're going to do, it's in that distribution menu. You press the second key, and then the button you're going to press is vars. And the reason you pressed the second key, and I have to go very slowly for this to work, is above that vars key, it says DISTR. That means distributions. That's your distributions menu. So this is the button you press, but you have to press second first to get to this. And when you do that, you get some choices. The second choice is normal CDF. You want to look for the words normal CDF. The first one might be PDF. You don't want that. You want CDF. It's used to calculate the area between two z-values. If you're calculating the area below a z-value like we are, or 1.27, you're going to use negative 999,999. That's 6 nines for the lower limit. That's close enough to negative infinity. If you were to calculate in the calculator the cumulative area to the right of a z-value, you would use the z-value you had as the lower limit, and then use an upper limit as positive 999,999, 6 nines. When you do this in your calculator, you get this normal CDF, and some of you will get a menu like they show on the next page, and some of you will get a parenthesis. I'll tell you what to put in those parentheses, what order it goes in a moment. So let's shut this off and go back to that and see if, there we go. So if you have a newer operating system in your calculator, you go to that normal CDF function, it asks you for the lower limit, the upper limit. Now if you're using a standard normal distribution, the mean is always 0 and the standard deviation is 1. What's good to notice here though is if you had a normal distribution that was not yet standardized, that you hadn't made standard yet, you could put the mean in here and the standard deviation in here. You wouldn't be using a z-score, you'd be using a data point probably, but you could still do that. But for now, our mean is always going to be 0 and 1 if we're talking about standard normal curves with a mean of 0 and a standard deviation of 1. Now the lower limit and the upper limit go there. Now if you were using an older operating system like the one I have in my calculator, you do this normal CDF and you get a parenthesis after it. And what you put in that parenthesis is you put the lower value. I'm just going to write low because it's going to take. And then you put the high value. In the case of this problem, the low value is negative 999,999. The high value is 1.27, and then you put a 0 for the mean. So this is the mean. Sorry, that's not going to write. And then you put the standard deviation last. It goes in the same order, but you just have to list the numbers. You would put negative 999. Just takes me a long time to write that. That would be a negative 999,999. Then you'd put a comma. Then you'd put 1, 1.27. That would pretend this 1.7, comma 0, comma 1. But it always goes low to high, mean, standard deviation. It goes in the same order as this slide would, only you have to write it out and put commas and put a parenthesis at the end. And it's shown this way over here in the older operating system. That's all that's saying, that right there. Okay, you can't see the 1 at the end, but you would see, you would have typed the 1 there, and you get this number. And when you get this number, that's your answer. That's your probability. So the probability of a person having a bone density of 1 with a z-score of 1.27 or below is 0.8979, pretty close to 90%. Pretty good. So we know that that's a person's within the 90% probability, and on the high side, that's good. So that would be maybe how a z-score would be used to interpret a test result. So now we interpret our result, which is what I just said. We could conclude that 89.8% of people have a bone density with a z-score below 1.27. So if you had a z-score above that, you'd be in the 90th percentile. You would say this person is in the 89.8th percentile, or maybe you'd round that to 90. And that's what you hear when you take a child to the doctor, and they say they're in the 90th percentile, they're in the 40th percentile. That means their z-score would give them an area of 90%. 90% of the population is there or below, or 40% of the population is there or below. So let me go to the next slide. I think we may be just about done with this here. So if I wanted to find the area to the right, so I want to find the probability that a randomly selected person has a z-score above -1, which is considered to be in the normal range of bone density readings. Z-score plus or minus a standard deviation would be okay. You would use the lower as a -1, the upper is 9999, positive 999, so, and then still mean is 0, standard deviation is 1, and you would find you got 84%. So being above a -1, to the right of -1, you've got the curve, you're now to the right is 84% probability. Or there's a 16% probability that you're lower than that. You could look at it that way too. So this is talking about a table. We're not going to do that. This is the interpretation of our result. 84% of the people have bone density levels with a z-score above -1. Remember, this is a z-score we're looking at. So what if I want the probability, the probability of somebody having a z-score between -1 and -2.5? Now you have to remember that -2.5 is actually less than -1. So that'll be your lower reading, and the -1 will be upper reading. Be careful of that with negative numbers. So again, normal CDF, I use the -2.5 for the lower, the -1 for the upper. If you get those switched, you're probably going to get an error message. 0 is the mean, 1 is the standard deviation. And I see there's a 15% score, 15% possibility that your z-score is between those two. And you would have 15% of people have osteopenia. That's if they're looking for your score to be between -1 and -2.5. I suspect if it's less than -2.5, they have another name for it, but they would interpret this as osteopenia if your z-scores are in that range. And there's about 15% of the people who have that. And I guess when you say people, you would have to define the population. Is it just older women, or is it everybody in general? We don't need to use the table, so we're going to move on. This is the summary. The probability that your z is between A and B says the probability of z. So this is, if your z-score is between two numbers, these are the two z-scores you're looking at. If your z-score is greater than some number, you're finding the probability that z is greater than the number. And this is how you note z less than a number. So if I ask you that the probability is, for the probability that some z-score in a standard normal distribution is less than 1, then I would write that as, and let me do this, probability. I have to write really slowly for this to work. z less than 1. We won't say it in words, we'll write it in these symbols. So you would be looking for so over here would be your 1. You would be looking for this area here to the left of the 1. If it was greater than 1, you'd be looking for the area to the right. If it was between 1 and 2, you would be looking for the area in between. All right, so there'll be one more video talking about what to do if you know the area and you want the z-score. That's using an inverse norm function on your calculator. Email me your questions and I'll see you next time.